Students, welcome to our today lecture. In our today lecture, we are going to discuss that how to apply quantile regression analysis while using STATA. We can apply quantile regression both on time series data and as well as on panel data as well. So why basically we are using quantile regression? Because when we apply OLS, it will only give us the result that how an independent variable is affecting dV. But it does not tell us that if there are certain levels, so on which level IV have a strong or weak impact on the dV. So for example, if we want to see that FD is having how much effect on the large economies or on small economies, or how any change in economic policies affect the low household or middle household or the people who are having high level of income. So when there is a distribution of the data set, so in that case OLS does not tell us that which distribution of the data set or which portion of the population is affecting more or less. So in that scenario, the quantile regression give us the best results. So in our today lecture, we are going to discuss that how to perform quantile regression. So as I mentioned earlier, that we can apply quantile regression both on panel data and time series data analysis as well. So first of all, we have to bring our data set. So here is my data set that is in time series. Then we have to go back again to STATA, then click on data editor and paste your data set here. So here it is asking you that treat first row as a variable name. So yes, we are interested that treat our first row as a variable name. So now you can see that here our data is now present in STATA. You can apply STATA both by command option and you can apply both by manual option by going to statistics. So when you go to statistics, so when you drag down here you can see that non-parametric analysis. So after clicking on the non-parametric analysis, here you can see that there is an option of quantile regression. So click on quantile regression, and here it is asking about that what is your dependent variable. So let's suppose we are taking GDPG is our dependent variable, and here you have to mention your independent variable. So GOV, POPD, FDI, GGE and INDV are my independent variable. And now here it is asking about that which quantile which you want to estimate. You can set it according to your own desire or the nature of the study of your paper, your article, your thesis, your project, your capstone. So let's suppose first we will be taking the result with the 50 quantile. So then click on OK. So now here you can see that it gives you the results for 50 quantile. So for the significance of the coefficient of any variable, we have to see the p-value. If the p-value is less than 0.05, then the results are significant, and if the p-value is greater than 0.05, then the results are not significant. Second thing is that in OLS result, we observe that it gives us R square, but in case of quantile regression, it gives us pseudo R square. So R square is totally different from pseudo R square. So here you can see that now it gives us the command as well. So if you want to apply through this command, so you have to simply write quantile regression. So QREG mean quantile regression, then your dependent variable and your independent variables, then comma, and write the quantile which you want to estimate. So now if we want to estimate like say 25th percentile, so now we go back to again here and click on non-parametric analysis, then click on quantile regressions, and now select for example 25th percentile, then click on OK. So now here you can see that now it has given us the results for 25th quantile. So you can see that at 50th quantile pseudo R square was 0.21, and now the value of pseudo R square changed from 0.113. So this is how we are distributing our data set. In above we have distributed our data into half of or like median, and now we have taken the 25th or 1/4. So now similarly you can apply this data set into like say 75th percentile non-parametric analysis, then go to quantile regression. And for example, at this time we are going to take 75th percentile. So now you can see that it has given the result for 75th percentile, and again pseudo R square change, and at this you can see that some variables are become significant, like population and the I and dv variables are significant. But when you look at 25th quantile and 75th 50th quantile, you will see that uh, more of the variables are insignificant, but at 55th quantile you see that our some variables become significant. So here you can see that every quantile has its own pseudo R square. So you cannot say that this pseudo R square is better than this pseudo R square and this pseudo R square is better than this. So the greater the value of pseudo R square does not tell us that which quantile is giving us the best result. It is according to the number of distribution that you have divided. For example, 0.1 pseudo R square may be better than the 0.21. So for example, if you have a 25th percentile and your pseudo R square is 0.1, and if you have 50th quantile and your pseudo R square is 0.2, so 0.1 is better than the 0.2, because with the very much low level it is giving us the more results. So it totally depends upon the interpretation and the nature of the study that you are doing. So pseudo R square is different for each quantile, and you cannot compare one pseudo R square with the other pseudo R square depending on its higher value. And the second thing is that uh, the p-value of each variable is telling us you the significant, that either a variable is a significant or not. So this is how you can apply quantile regression on your results, and this is how you interpret the results of your quantile regression. So if you have any query regarding this lecture, you can ask me freely. As in our today lecture, we have applied quantile regression on time series data, but you can apply quantile regression on panel data series as well.